Hi, math analysis. Starting the last section, 10.7 probability. Empirical probability. Empirical probability applies when we can count how often an event occurs. The probability of a particular event is denoted P of E. So probability of E is the number of times E occurs over the total observation. So the chart shows mammogram screen results of 10,000 U.S. women ages 40 to 50. So a positive mammogram, somebody that does have breast cancer, is 720. Not breast cancer is 6,944. A negative mammogram for somebody that does have cancer is 80. So that would be a false negative. And then no breast cancer was 92,256. So it says find the probability that a woman age 40 to 50 has a positive mammogram. So you want to add up all the positive mammograms. So you want to add the 720 plus 6944, and that's over your 100,000 women. And then you reduce the fraction. And there's your probability. And you can just reduce on your calculator. If you have the graphing calculator, go math, fraction, fraction. Among women with breast cancer, find the probability of a positive mammogram. So you want to add up all the women that have breast cancer. So that would be 800. And then positive mammograms would be 720. And that's going to be a higher percentage. That's a good thing. That means the test works better. Among women with positive mammograms, find the probability of having breast cancer. So you want to add up all the positive mammograms. So all the positive mammograms, 720. Among the women with positive mammograms, so that would be 7664. And then find the probability of having breast cancer. So that would be 720 over that. And then you just reduce that. Now, I know you've done probabilities before, so this is going to seem pretty basic. Okay? It's just using a chart to help you with the probability. Okay, so theoretical probability. Probability is chance or likelihood of an event happening, often is expressed as a ratio of a number of successful events to the number of total events. So that's what that probability, number of times the event occurs and the number in the sample space. And the sample space of an experiment is all the possibilities. So you mostly work with theoretical probability. So when we take a look at the sample space of rolling 2 dice, there's 36 members in the sample space, and you can see in that sample space they're all the different possible rolls. So there's 36 of them. A die is rolled. Find the probability of getting a number greater than 4. So a die is rolled. Oh, so this is just rolling 1 dice. The second one is rolling 2 dice. So a die is rolled, so just 1 die. So that sample space is just 6 possibilities. Find the probability of getting a number greater than 4. So that would be 5 and 6, so it would be 2 out of 6, which is 1/3. Now, the sample space for rolling 2 dice is there, and that's 36. 6 times 6. What is the probability of getting a sum of 5? So you want to add up all the sums that are 5 in there, and there's 4 of them. So it would be 4 out of the total, which is 36, and then you would reduce. So pause the video if you need a little more time to understand or write this down. All right, so quick facts about cards. There are 52 cards, 26 black cards, 26 red cards, 4 suits, spades, diamonds, clubs, hearts, 13 in each suit. Face cards are jacks, queen, and kings. Aces are not face cards. Hearts are red, and diamonds are red, and spades are black, and clubs are black. If you are dealt one card from a standard 52 card deck, find the probability of being dealt a king. Well, how many kings? There are 4, so 4 out of 52. And then you would reduce it. Suppose Chris draws 5 cards from a standard deck of 52 cards. What is the probability that his hand contains 2 cards of one suit and 3 cards of another suit? So 2 cards of one suit and 3 cards of another suit. So you're going to want to do combinations here. So let me explain this. There are 13 in each suit. So out of the 13, you want 3. And so order's not going to matter what order you deal it with. So it would be 13 combination 3. And so that's multiplication times 13 combination 2. And then the possible sample space is 52 combination 5. And we learned all the combinations in the last section. So now you want to get your calculator out and plug in the combinations. So 78 times 286 over that large number. And so you can do some reducing there and get the fraction. All right, 3 stuffed animals are to be chosen randomly from a group of 3 bears, 6 tigers, and 4 lions. Find the probability of selecting 1 tiger, 1 bear, and 1 lion. So that's going to be 1 tiger, so 3C1, 6C1, 4C1, over how many stuffed animals are there, and you're selecting 3 of them. So there are 13 stuffed animals, and you are selecting 3 of them. And then you want to multiply out the 3, the 6, and the 4 together and over 286 and do some reducing. So when you just want all 3 to be bears, that would be 3C3 for 3 bears, and you want all 3 of them over 13C3. There you go. Okay, so a lotto is set up so that each player chooses 6 different numbers from 1 to 49. With 1 lotto ticket, what is the probability of winning a top cash prize? Well, express the answer as a fraction and as a decimal to the nearest 10th place. So we know that there's 49 numbers, C6, but there's only 6 right numbers and you want all 6 of them. So that's going to be 1 over 13,980,000. And I'm not going to worry about it as a decimal. It's a very, very small decimal. So we'll skip that portion. Okay, so complementary events are 2 events where the probability adds up to 1. So if you want to find a probability of something happening, you could find that it not happened and subtract it from 1. So this table gives the number of active duty military personnel in thousands. If a person randomly is selected from the U.S. military, find the probability that this person is not in the Marines. So you've got not in the Marines. So you want them to not be in the Marines. So what we could do would be 1 minus probability of being in the Marines. So the probability of being in the Marines is 180, because that's the sum of men and women. Um, 170 plus, I think that's, sorry. Yeah, I just went 180. Sorry about that. It was 170 plus 10, which is just 180. And over the total, 1430, and you're just subtracting that from 1. So I know that this is kind of unclear, so that's 1430. Okay? The other way you could have done it is add up all the other ones and put that over 1430, but it would get you the same answer, and it's quicker. So, mutually exclusive. Two events that, oh, there's it all fixed up better. Okay, mutually exclusive, two events that never occur at the same time because there is no overlap. So the probability of a mutually exclusive event, probability of A or B happening, is just the sum of the two things. So or is always addition. So there is no overlap for mutually exclusive events. So you reach into a bag containing tiles of 1 through 10. Find the probability of drawing an even number or an odd number. So you've got even numbers and odd numbers. There's 5 even and 5 odd. You add it together. It's 1 is the probability there. Okay, an inclusive event. Two events that can occur at the same time. They have at least one element in common. So you have to subtract the overlap there. So you reach into a bag containing a number of tiles, 1 through 10, find the probability of drawing an even number or a prime number. So there are 5 even numbers, plus there are 4 prime numbers. 2, 3, 5, and 7 are prime, minus the only even one is a 2, so there's 1 even. So that's why that you have minus 1/10 there. Okay. All right. Determine whether it's mutually exclusive or inclusive, then find the probability. A restaurant has 5 pieces of apple pie, 4 pieces of chocolate cream pie, 3 pieces of blueberry pie. If Janice selects a piece of pie random for dessert, what is the probability that she selects either apple or chocolate? Well, this is mutually exclusive. It's got no overlap. So apple would be 5 out of your 12 possibilities. And then chocolate is 4, and you add them together and you reduce. All right. A department store employs 28 high school students, all juniors and seniors. 6 of the 12 seniors are female and 12 of the juniors are male. 1 student employee is chosen at random. What is the probability of selecting a senior or a female? So there is some overlap. So let's make a little chart. It says 6 of the 12 seniors are female. So that means the other 6 are male. And then it also says and then at 12 of the juniors are male. And then it says 12 of the juniors are male. So we know 12 are male. And we have to know that there's 16 because there's 28 total. And there's 12 seniors. So there's 16 juniors. And so there must be 4 female. So you have that little chart there to help you out. You do have some overlap. So it's 12 out of 28 plus 10 out of 28. But then you've got to subtract the overlap because it says what is the probability of selecting a senior or a female. So you have to subtract the senior females from that. So what I didn't write down is this is inclusive. Okay? Alrighty. A local gym, 80 members were surveyed about which aerobics classes they were taking. Determine each probability of a person. So there is overlap, and there's 80. So since there's 80, and the numbers in there don't add up to 80, you know 18 don't take any. So you have to have that. So probability of step aerobics or jazzercise. So you're going to say it's going to be 13 out of 80. That's the middle. You know that's the middle from the Venn diagram. That's the 13, that's the overlap. So we already know that. Step aerobics or jazzercise. So you're going to take the 35 that takes step plus the 40 that take jazzercise and might subtract the overlap of 13. So I added the step aerobics circle, I added the jazzercise circle, and then I subtracted the overlap. All right. Okay, last part. Probability of A and B. So find the probability of a series of events. We multiply the individual probabilities. With independent events, the outcome of the first event affects the future events. Does not affect the future events. So, a roulette wheel has 38 number slots, 18 black, 18 red, and 2 green. Find the probability green occurs on 2 successive plays. So that would be 2 out of 38 times 2 out of 38. And it's helpful to reduce before you multiply here, just because it's an easier reducing. Find the probability of a family having 4 boys in a row. Well, you have 50% chance, so 1/2 times 1/2 times 1/2 times 1/2. Each child. Okay. Right. Any questions? So that's when it's independent. Okay. When it's dependent, which for some reason is not in these notes, you have to take into account the event. So, for example, if you have 5 blue and 6 green marbles in your, and you take a marble out and you don't put it back, and you want the probability of 2 blue, then it's not just going to be 5 over 11 times 5 over 11. It's 5 over 11 times 4 over 10. So that's what you would have to do. That would be 20 over 110, and then you would have to reduce that. So that would be if there is overlap. So let's multiply. I just added this now, so let's just reduce that. So we've got 20 over 110, and I'm going to go math, enter, enter. It's going to be 2 over 11. You could probably do that. So that would be, I don't know if they do mutually exclusive. I believe they do. So I thought I'd do an example of, of a dependent event. So this would be a dependent event instead of an independent event. Okay, guys, have a great day. Thank you.